Welcome back, chat. Today, good news, no one's getting chopped. So we're just going to kick forward. Looking at it, I asked you guys to do two things yesterday, and I did them, of course. And we're all going to come to an agreement that ... some work happens, right? Now, I'm going to show the first little step of work that I would encourage that I didn't tell you you had to. But here's my hope. I'm just going to switch to red. I'm not going to differentiate the colors. When we do this, I assume that you use the fact that f plus g of x expands to be f of x plus g of x. Okay, that means when you look at stuff, you probably have x squared plus 2x plus 2x minus 1. Pretty confident that's going to be on your page. Okay, follow-up question. Did yours have parentheses?
Yes.
Okay, some of you do, some of you don't. Do the parentheses change anything here?
No, this one.
Not at all. It is a good practice. I will typically include them, and then if I don't need to use them, the very next line, they're gone. Like right now, I'm just going to imagine they're not here because there's nothing happening. They're multiplying by one outside. Okay, I think we get x squared plus 4x minus 1. X squared plus 4x minus 1.
Yeah.
Rodeo, same thing.
What? No.
What did you get?
I factored the x squared plus 2x.
Okay, so you went here, x times x plus 2.
And then it's on x. X equals 0, x equals 1.
Ooh, I like what you've done, but I don't like what you've done simultaneously. Did you solve something? Seemingly? Why? Where did we say to solve? That'll happen. It's a really common thing. People naturally, when you see an equation, you probably like remember setting it equal to 0 like 90% of the time. Unless you're told to solve or to find the intercept, like something specific, we'll try to avoid it. Do you understand how I got this answer, Red?
Yeah.
Okay, you've done, hold on. You're doing too much. All right. That one's kind of dead, but we're going to bring it back. Is it dead?
No, it's, I don't.
Okay. Doing too much?
Oh, maybe.
All right, this one. X squared plus 2x minus 2x minus 1. If you don't include the parentheses here, you're done. Gosh, I am following all through these. She's one of my favorites, just so you guys know. Why do the parentheses matter here?
Redistributing it.
Yeah, if you don't have these parentheses, you're going to have a minus 1 in the end. We shouldn't have a minus 1. We get x squared plus minus 2x is just 0. Plus 1. Cool. All right. Doable?
Yes.
All right, these ones are less fun. Okay, let's get real. These are all fun. C. Together, or do you guys want to try one?
Try. Is it same or different?
We're going to do f times g of x. Okay. I'm going to pause my video. I'm going to start working this, showing a bunch of work. You guys might not show as much work. Try to avoid looking up until you have an answer or you're stuck. But I'm going to work it simultaneously, and then we'll see, even with showing work, who finishes first. Cool. Let's see what we get. Checking this out. You guys probably didn't include this, but it's a good practice, and we'll see it really with the compositions. F times g of x expands to f of x times g of x. Most people probably jumped in right here. Okay. If you can FOIL in your head, am I cool with it?
Yeah.
For sure. If you FOIL in your head and get it wrong, how much partial credit are you going to get? None. So, your call. Did I make a mistake foiling? I don't see one, but I could have. Did everybody come up with this? 2x cubed plus 3x squared minus 2x.
Yeah.
Okay. Super difficult?
No.
Okay. This last one we're going to do together. How much do you guys remember about, what's the only other operator? We did addition, subtraction, and multiplication.
Division.
Hey, how much division do you guys remember?
Oh, I do.
How about with polynomials? Okay. Forget it all.
Okay.
Not forever, just for right now. Okay, if we're trying to do this, this is f of x over g of x. Now, you do not have to write the first one today with these ones. I will make you do it with compositions, though. There's a reason we do it. F of x over g of x. Everybody okay with that? Okay, this means to divide, right? However, this is called a rational function. we're not going to do the division. We don't have to long divide. Sorry, we don't get to long divide. We don't get to synthetically divide. We just stop. There's only one little thing that we need to do. What was f? So x squared plus 2x over 2x minus 1. We are 90% of the way done. This is it. This is all that we do with one little thing. I put a semicolon here because I have a caveat that we need to pay attention to. I'm going to do a little bit of scratch work. What do we say about g of x? What can't it be? Okay, so I'm going to do a little bit of scratch work off to the side. Normally, and I'm okay if you do, this might be mental work, but if we need to show it, we can. I need to know when is 2x equal to 1, sorry, 2x minus 1 equal to 0. I'm going to add 1 and divide by 2, and I think I get 1/2. So if x is 1/2, the denominator is 0, right? Is that allowed?
No.
So we should probably specify that x cannot be 1/2. Now I've gone back and forth, and this is purely a stylistic choice for you guys. This is a work to find the 0 of the denominator so that I know what makes it 0. Addison, your question first.
Why can't we get rid of the 2x's? Sorry, it's not like.
Like, why can't we do this?
Yeah.
So check it out. Let's do 2 plus 3 over 2 plus 5. That's 5. We'll actually do 2 plus 8 to make it nicer. Do you agree that that's 5 over 10 is 1/2? What if we do this? The only time that you can factor out is when you have dividing by something divided by itself or something similar. So if we added this now, and we did this, could I factor an x out of the denominator? And I could do this. We'll get rid of them. I don't know why I even wrote them. At this point, I have x over x and this other expression. Here's what divides out.
So it's multiplication.
Yep, factors. Common factors in both. Great question. Did that clear it up? Cool. All right. Stylistically, just out of curiosity, because this is inevitably going to come up in my Algebra 2 and other classes, I can't decide which one makes more sense. When I do this scratch work, I find the 0 and say that it can't equal it, and we solve the equation, right? Could I solve the unequation as well, or does that feel clunky? Like, it's the exact same work, everything's the same, except we're already from the get-go saying this is what the denominator can't be equal to, and we just solve it like normal. Is this wonky for everybody? I kind of love it and I kind of hate it. Your guys, like, there's no right or wrong. Thoughts? Thumbs up if I should teach it this way, thumbs down if just do it the other way. So instead of solving equals and then changing it, we could have just said it not equal to begin with. But if there's confusion about it, I don't think that that same confusion exists if we just do it equals, so we'll just roll with that. Okay. All right. Do we need to do any more of these? Okay, we will do some word problems with these soon, but let's move on to our more fun part of it. Compositions. So composition of functions. You guys, I'm pretty sure last week I asked you if you remembered ever drawing mappings, and you guys seemingly didn't, and then I drew the pictures of domain and range and the arrows, and then all of a sudden you did. Okay, here's the deal. I'm not going to record this one. I'm not going to record this. I'm going to draw it on this board. Can everybody see that board okay? The one right there in the middle. Here we go. Let's get crazy. Composition of a function. This is a non-arithmetic combination. Non-arithmetic. And I'm going to use combo from domain of, I'm going to use G and F, domain of G, to range of what function? F. Now, we'll be more specific. In general, we wouldn't use G and F like this, but it happens like this. Now, when we write these things out, there's a bunch of different ways that this can go, and there's a much more important reason that we'll see that we use these for eventually. But as we look at this, we're going to define it as follows. And we'll just say, I'm going to put a star here because it's an important one. F composed with G. Notice it's like the degree symbol size, but it's right in the middle. It should not look like an O. It looks like fog, but it should be like very clear that it's not the letter O. f composed with g of x, by definition, equals something. And this one's not as natural, but if we come back to this picture, we're going to be able to reason it out. I want to go from here to here. If I were to take 2 steps, what function would I use first? So I start at these x values. What function takes me from 2 to -7 on that picture? So we did g first, right? And then once we have whatever g of 2 was, we plugged it into which function to get from -7 now to pi? We use f. G happened first, right? So when we see this, it's weird because notice g is not first in this list. But when we write it a little bit differently, it'll become super duper clear. I'm going to switch colors for one part of this. F of g of x. This is f composed with g of x, or much nicer to say, f of g of x. Okay, does this look familiar to you guys? Pretty much. Like, you can pick any other 2 letters. Like, we can name our functions whatever we want. H of L. You could do the same thing. We'll see a word problem where we might pick different letters just to make sense of. But together, let's just make this sense. I use some pretty common language that we need to make sure we all agree on. Once we're here, what is the inside function? Everybody agree that this certainly looks like it's the inside function? G is inside function. I'm going to put quotations around that for inside. Because, I mean, it literally is when we write it like this. It's harder to tell here. But if we do want to look from here, which you won't, but if you did, is G in the middle? In the middle would be inside rather than outside, right? So we can see it happens here too. If G is the inside function, what's the outside function? F. F is the outer or outside. I'm going to call it outer function. Can we agree on that language? Okay. Now, I think most of you, I guarantee everybody has seen this, but whether you were super comfortable with it, I don't know for sure. We're just going to get comfortable with it by doing some examples. Okay. Now, every single time you do it, on the ones that we did yesterday with the arithmetic combinations, did anybody write this on your page when you did the problem? F g of x becomes f of x times g of x. Some of you might have. Not everybody. I guarantee not everybody. For this, there's not very many times that I say do exactly like this, but I want you to write these definitions. At least for today and tomorrow, when we get a composition, I want you to write this as your very first line. It will help. Now, I'm going to do a lot of color changing today. You never have to, but I do think that if done correctly, the color changing makes it really easy to see what's moved. I have colored pencils that you can shove underneath your fingernails if you're not careful. I have a bunch of them here. You guys can use these anytime you want. I also have wonderful packs of colored pencils if you want to take some home to do homework and stuff. If we're dealing with more than one function, this is a way to organize it. I will do it up here. I would do it on the board if I had markers. If I just had a black and white pencil, actually not a white pencil, I just had a regular black pencil, I probably wouldn't do it. You guys are welcome to use these. I'll be super proud if you do. I'll be super proud if you don't. If I don't say it, I'm sure I've said it before, I am super proud of all of you guys, just so you know. Cool. I was really scared this class was going to have like one person, but it didn't, so we're cool. All right, composition of functions. Let's knock some out. Weisha, what is your favorite quadratic function? Has to be squared. That is a nice function. Okay, so we have f of x on A, and we'll name this compose, but we'll look at a few of these. Let's look at another one. We're going to make this one linear. Matilda, what's your favorite linear function?
I was gonna put a fraction.
Don't do a fraction. Make it nice for the first one.
3x plus 6.
3x plus 6. Okay, notice I have used black and red. Okay, we're going to use this, and this is weird because normally examples are just A and B and C, but we're just going to use A, and we'll do, I don't know, do you want to call it A sub 1, or do you want me to use like these? I'll use that. I like that. That's fine. Okay, here's what I want us to do. First thing, I want us to find F composed with G of X. Now, immediately, if you didn't catch it, hey, like what you're doing there, Basil. If you didn't catch it initially, I want us all to start the exact same way. I see F composed with G, or fog, maybe is what I see. Very first thing, I'm going to apply the definition of a composition and what it looks like with math. This becomes, uh-oh, I forgot. Abijah didn't. F of
G of A.
Good. F of, and notice, I wish I had a faster way to do this, so you're just going to have to deal with the clunky changes from time to time. F of G of X. Okay. Now, we're going to take little steps to begin with. If you're comfortable with big steps, I'm fine with that on the homework and stuff, but right now I want you to take little steps with me. This becomes F of, gosh, what's G of X? Confidently, whoever whispered it. Was that any more confident? All right. 3x plus 6. Notice, I just plugged it in, right? Now, let's just think about what this means. When I say evaluate f of 1, you literally, anywhere that there's an x, you replace it with a what? If I did f of 1. You would plug in a 1 for every x. What if I did f of pi? Every x would be replaced with pi, right? This time it's uglier, but it's f of 3x plus 6, which means in my outer function, anywhere that there's an x, what should I replace it with?
3x plus 6.
Absolutely, it's 3x plus 6. Now, again, the colors help. You don't have to, but I would strongly recommend it. My function is just 1x squared. Notice, here's where my x would go. It's gotten bigger. It's not just x anymore. Plus 6. What's going to go inside of those parentheses? Confidently, again, Wisha says 3x plus 6. Okay. We have successfully completed the first part. Red. So, whoa. Nope, I'm wrong. Red asked a great question. He said, where'd you get the plus 6? And I looked at him like he was silly, and I said, oh, right here, duh. But Holloway is the silly one. F of x is x squared. Here's x, my new one, squared, plus what?
2.
What is this? I wrote 6. What is f, though?
2.
It's 2. Look at that, color coding saves the day. Thank you, Red. Sorry if I gave you attitude. All right, is anybody here a freshman?
No.
Okay, so that's definitely not 9x squared plus 36. Okay. No freshman dreaming. What does it mean to square something? Times it by itself. Do we want to FOIL together, or can I say you guys FOIL and we'll meet up at the end of it? All right. I'm going to give you guys, I don't know, 30 seconds-ish? Or less? 9x squared plus 36x plus 36. You got 38? Oh, plus the 2. Okay, I was just looking for the FOIL part, but you're good. Okay, I'm only going to do black now because I've plugged it in. I think 9x squared plus 36x plus 36, and then plus 2 out here. Addison, you can say no, but are you comfortable in saying where your mistake was?
I multiply 3x plus 6 times x squared plus 2 instead of squaring it.
Okay, I think that's just an odd mistake. I don't think okay. Am I done?
No.
Almost. I'm just going to combine my like terms, right? 9x squared plus 36x plus 38. And look at that, we now have our lovely composition. Okay. I'm going to demonstrate this little two-step thing. The first one, I'm not going to make us work it out, okay? Like, we'll talk it out. You don't have to write anything. If I wanted to find f of g of 2 using this picture, that domain mapping, if I plug in 2 here, I could do g of 2 pretty easily. What is g of 2? 6 plus 6, I think? It's 12, right? So I take 12 and I put it in my pocket, and I go, okay, there's a function f, 12. It's now f of 12. 12 squared is plus 2. So what we just found out is that if we do the composition in that patented two-step process, we just got 146. Is everybody okay with that? I want to see what happens here, though. 146 is our magic number. This one, same two functions. I'm going to call this 2. Doop, doop. Yes?
Can you explain that one more time? How you got 146?
Absolutely. Okay. If I'm using this picture, and I'm trying to find f of g of 2. Here we go g of 2 first, right? So we'll even change the numbers. Look at our function that we have. 3x plus 6 is g, right? What's g of 2? So if you plug in a 2 for this x and this x, we get 3 times 2
Oh, 6.
plus 6.
12.
So here's what that mapping would look like, from 2 to 12. Now we need to take our second step. So I'm going to plug in this 12 into which function? What takes me from here to here?
So you put the 12 in for the x.
In which function?
The
Like,
f.
good. Yep, and this is like, you can look there, that's fine, but this is what I'm plugging into. Plug in 12 and f spits out, and let's just see. So it's x squared plus 2, and we're plugging in 12. 12 squared is plus 2? 146. So this is the mapping picture, right? Okay, here's what I want us to do. Without using that two-step process, I want you guys to expand using the right notation first, but I want you to verify and find f composed with g of 2. Now, there's very little thought that has to happen here. I don't want you to do the two-step. Do we know what f of g is already? Okay, it's right here. We know it. This is going, and I'm going to change colors one more time. We're going to do this one together rather than having you do it on your own because I'm afraid people are going to try to take 2 steps. Okay, if we wanted to do it all out, we could use those 2 steps and we should write down exactly what we said. But we just said what f of g of x was, right? So let's try it. This is f of g of x. If I do 9 times 2 squared plus 36 times 2 plus 38. If everything works out okay, we should theoretically wind up with what number?
146.
Let's hope that this works. It should be. If it's not, there's a bigger issue we got to deal with. But okay. Mental math. Do I really care if you can mental math? Not super. I want you to be able to do math, and mental math is always more efficient. There are sections of the AP test that don't have calculators, but they're usually not like, I'm not concerned about anybody's mental math. What's 2 squared?
4.
So now I have 9 times 4, plus, that's 72, plus 38. I would add these.
110.
Yep, that's what I would do. Plus 36. What did we just get on the board over there? Hey, so check it out. Was this, like, we'd already done the problem, but is this noticeably, and maybe not by a lot, but is it noticeably more efficient than finding g of 2 and plugging it in and finding that ... I do some work and I get g of 2 is 12, and then doing f of 12 and getting ... do some work, 146. Like, we're doing it all in one step. Is it obvious that this does save time? Okay, there are lots of real-world situations where one would care about this. Cool. Well, if f composed with g is doable, are there any other combinations that we could do? Well, oh my gosh, we could do g of f, right? Thanks. Let's do it. And by let's, I mean, hey, you guys do it. 1, 2, 3. This is the third little thing. We're using the same function. I want you to find me goff. G composed, not capital, G composed with f of x. Everybody's first line should be changing this kind of misleading statement to G of f of x. That's step 1. I'm going to give you guys a minute and I'll do some ... I'll even start with my first step. G of, oh no, I'm going to switch colors. G of cool. I'm going to give you a moment. Okay, so just to check really quickly, I'm not going to switch my colors around. This becomes G of what? G of f of x is G of x squared plus 2, right? And now I just look back at my function G that's defined as this, and I say, oh, anywhere that there's an x, I'm going to replace it with x squared plus 2. There it is. We distribute. We get 3x squared plus 6, and we stop here. We're done, right? Okay, is there another combination that we could have done? Like, this one is going to be the last one I'm going to make you guys do. This is 4. And then we got a word problem. Love it. And then a super weird assignment. I want you to find me, are we feeling goggy or foffy? Gog. I want G composed with G of x. And I'm going to do that also.
I just did it.
Yep, I'm going to do it right now too. Work on this problem, and then we'll come back together and we'll talk about this some more. Sweet. We have composed G with itself. We could compose F with itself all the same. Okay. Interesting question. Yes, ma'am. Are you okay with we get 9x plus 18? And then what do we still have to add? Yep, that's, and I skipped one line. That's my bad. I should annotate that better. Okay, thank you for asking. All right, I'm going to give you guys 60 seconds. You guys have a head start here. Does the picture on the board help you guys think about what's actually happening? It helps me a lot, but that doesn't mean it helps you, right? Like, it could be different. Here's my challenge. I'm going to give you guys 2 minutes. I'm going to write a word problem up on the board while you guys are chatting. You do not have to write the word problem as well. I'm going to find where it is in the book, so we'll just reference page whatever, so you don't have to write a paragraph. But I want you guys to discuss the domain of G could get, or sorry, the domain of the composition could get weird. Because there's some situations where it might be kind of hard to talk about. Your challenge. How would you describe the domain of f of g of x? We can use that picture up there, and I might add some more to it. But I just want, how do we try to lock in and talk about it? Because we can't just say it's all the x's that you can plug into it. Maybe. We'll see if that works or not. But I want you guys to talk about it. 2 minutes. How would we define the domain of the composition is the question. I don't expect anybody to get it perfectly. In fact, I kind of expect people to get it really wrong, but that's okay, because we can build from really wrong. Sweet. 2 minutes. Talk it out.
Domain for f of g of x. You could say the domain is f g of x. And,
Yeah, I want you to explain to me what the domain of f composed with g would be. Like, not for this particular
What is
function,
up with you and pizza?
just in general. How would we talk about it?
I think the last one was the tomato sauce.
Very good.
And
Well,
then
very
the
good.
range we're trying to find the domain.
That's not domain.
The range for like.
Oh, okay. Like, for real, you're not saying? I just heard you saying pizza. I thought you were talking about domain. Don't deal with these functions. Do it in general.
That's all I think.
Well, like, not this is how I understand it. That's how I know.
leave it alone.
Leave me alone. That's how I think.
Leave it alone. Leave it alone.
Just kind of
It's always gonna equal to.
why is she angry? I'm not angry. I'm just saying. She's a very interesting
Here we go. What function do we plug into first? Let's forget about this picture. Let's look at this picture. If we're looking for the domain of f composed with g, if we look at the mapping, what happens first? G, right? G happens first. It's on the inside. That's the first thing that we would apply. Now, there's a whole domain of G that exists. And it could be a bunch of things. It could be all real numbers, for example. It doesn't really matter. I'm going to add a couple little pieces to it. And let's see if we can make some sense of it and see where it gets weird to talk about. Okay. We will start tomorrow with the word problem. In fact, maybe tomorrow's word problem will just be our bell ringer. Okay. Cool. So we'll do that. But I'm going to list a few things, like maybe it's 2, 3, 4, 5, 6, and 7. Okay. Now, it could be a bunch, right? Hypothetically, let's say we get the following. 2 goes to 12, and we'll just make this nice and simple. 3 goes to 13. 4 goes to 14, I missed one. 6 goes to 16, and 7 goes to 17. Okay, there's nothing crazy there, right? Now, it depends on the particular function, but is it possible that when I look at my next mapping from here in what we now call the domain of F, that this number goes, I already had a number here, so we'll just use that one. That one's about dead. We're going to let it recharge before we just bomb it out of the trash can. I'm going to change color. Okay, maybe 12 goes to 146, yeah? And maybe 13 goes to 7. I don't know. 14 goes to 5. But 15 can't get plugged in for some reason. So maybe my function, just to show you an example of one, maybe this was my function f, and 15 just can't get plugged in. That could happen, right? If I have these 3 missing, maybe this is my function. Like, this could happen. And we don't have this function. I'm just making one up. If we stick with the simpler version, is there at least a possibility that there's a number in the range of g that I can't plug in here? Okay. So now, here's the issue. What people generally try to think is they look at this and they say the domain of this thing is just the domain of g. That is a natural thought to have. It's my first thought when I think about them. That didn't work though. So we need a way to explain all these values that give me values here that I can plug in here, which it's a mouthful, right? Okay, I'm not going to make us write this right now, but here's how I would define it, and I will define it. We don't have a whole lot of domain questions about it. We will revisit it, I'm sure, on the AP practice stuff. But, okay, the domain of a composition consists of the domain of G such that the range of G is part of the domain of F. That's a mouthful. Check it out. We'll summarize it tomorrow at the start of class. All right. Later, Raiders, no additional homework tonight, huh?
Nice.
Bummer.